Good afternoon, everyone. I'm going to give everyone a few moments to file in and get seated and comfortable. And once I see that most have joined, I will get us started. Perfect. Alrighty, so good afternoon, and thank you for joining us today for the Road to Color Consistency. I am your host, Jahalis Newbound, Digital Media Coordinator at Annex Business Media. Today, I am delighted to welcome the audience of Print Action Magazine to our 60-minute webinar brought to you by Fujifilm. Fujifilm Canada Incorporated Graphic Systems Division is a global solution provider in multiple segments for the printing industry, including commercial and industrial. Fujifilm is an industry leader on color knowledge and leverages its 85 years experience in imaging and has a proven commitment to investments in R&D, infrastructure, and skilled segments experts, supplying print service providers the best products and consultative solutions to consistently help to improve business operations. Solutions include equipment and consumables, as well as workflow, color management, and consultant services. Before I introduce our speakers this afternoon, I'd like to go over a few housekeeping items. As always, this webinar is being recorded, and a link to the recording will be sent out in 24 hours. Questions for our speakers are welcome and can be submitted through the Q&A function at the bottom of your screen. If you run into any technical difficulties, please also let me know through the Q&A so that I might assist you. Without further ado, I'd like to welcome our two speakers. Angus Pady has worked in the printing industry for over 25 years and is a G7 certified expert. He has worked with thousands of customers across Canada, helping with the implementation of color management technology and strategies. Our second speaker is Patrice Paquette. Patrice has worked in the printing world since 1987 and has been entirely devoted to color management since 1998. For the last 20 years, he's been dedicated to Fujifilm Canada. He is also a certified G7 expert since 2008, and his job leads to work with craftspersons in both conventional and digital printing in order to implement effective color management. Thank you for joining us this afternoon, gentlemen, and I'd like to turn the floor over to you.
Thank you.
Excellent. Thank you very much. So thank you for that introduction and welcome all of you to the Road to Color Consistency. The only part of that was left out is that I look after Ontario to the West Coast. Patrice is the Quebec to the East Coast. And we are obviously here with Fuji. So today, the goal, obviously, we're not going to solve all of the world's color management challenges, but hopefully we can share with you some really valuable nuggets that you can take away and use in your shop to improve color consistency over time. So that is our goal. So as we travel out and we talk to customers, a lot of times we'll come across and we'll say, what is the challenges that you face in your shop? What is the issues? And a lot of times we'll hear them say, we really don't have the time or the resources available. We're challenged with, with taking time. And I look at that and I counter and I say, okay, well, I counter with a question. So how much time do you spend each day chasing color? So if we can put a number on that amount of time, most of the shops, I would say conservatively, would say they're by probably 20 or 30 minutes a day that they're spending on color challenges. If you're in the 5-minute range, then you're doing really well. Your shop is a shop that is probably doing good in color matching. But if your shop is on the 30 to 35 or 40-minute range, then you may want to take a look at that. And you may want to decide, okay, how much is that time costing you? Okay, so let's take a little bit of a look at that. If you're a shop that's doing $1 million in sales, okay, that means you're doing approximately $4,000 in sales a day, okay? So if you run one shift and in 30 minutes, you are probably, so if you run one shift a day, then that 30 minutes of not selling, then you're losing out on approximately, I don't know, say $500, would you say? Now, if you multiply that $500 by 249 days a year, there's a potential that your shop is losing out on $125,000 in sales, right? That's a pretty big number. So if you take that now and you think, okay, now our shop is, not printing for 30 minutes a day, what is the value of that? What is the number that you can put on that time, right? Once you put a number on that, then you start to be able to sort of think, okay, is there a ROI on being able to implement color management? If we could take that time and cut it down by half, let's say, right? So now you're looking at maybe a $70,000 savings in gross revenue, right? So if you don't know what your shop is doing on the floor in terms of how much time that they stop to do color adjustments, go through maybe trying to match a proof, or trying to get color up to speed on the press, if you're not aware of what that number is, go ahead and ask the guys on the floor, say, how much time do you spend, not printing? How much time is it that you are, stopping production and not able to produce printing? And try to get a feeling of what that number is. That is really where we want to start, because we want to take that number and reduce it down to a very, as low a number as possible, right? That's the goal of a color management system, is to be able to make things just pass through without stopping, right? Without having the pauses that's in there. Statistically, the majority of print shops, and in our evaluation, probably 60% or more of print shops are looking to implement a color management strategy. So there's certainly a desire there. It's just, how do we start and how do we get involved in this, right? That's usually the first challenge. So the goal of this seminar, as we said, is not to solve all the problems, but really to give you some nuggets, to sort of show you what are some simple and effective ways that we could implement some color management tools, right? Because we want it to be simple, we want it to be fast, and most effectively, we want it to be something that you can make that ROI on. So coming back to that 30 minutes, can we reduce that down by half or less? Okay.
And Angus, I can add that the key word is simplicity, to make it simple, because otherwise sometimes it can be pretty much complicated. But at this time, the key word is simplicity that we're looking for. Absolutely,
that's very true. So in the past, our graphic arts industry has been a very subjective based evaluation. We all know the scenario where we're looking at a proof and we have three people who are, looking over the proof, and three people are going to give you three different evaluations. And a visual assessment, it's been our tradition in this graphic arts and sort of artisan type of an environment, but we need to move to a more print manufacturing, a more metric-based, a more data-driven, sort of scientific-based manufacturing, mindset, right? We can't retain what we printed a week ago. We can't remember, the color match that we printed 3 days ago. But if we have data, if we're collecting data and we're saving that in it's something we're going to show you over time here, then we get an ability to compare and trend and see what's happening over time. So the goal of color management we're seeing now is to move into a more data-driven, more scientific, and even in some cases, a cloud-based solution. Okay, so no measurements, it means no control. So that's very, very important, is to have that control, and the control comes through measurements. Okay, so implementing color management efficiently, there's really 5 steps that we're going to talk about here. One is to establish color references and standards, right? You need to have a target in your shop in order to be able to reference to and correlate to as time goes on. If you don't have a target, then how do you compare where you are, right? So we need to have a reference. The next is to determine what's an acceptable reference or acceptable tolerance for that reference, right? So an offset press is obviously going to have a higher tolerance than a digital inkjet press or an Epson, of course, right? Because the volatility that's involved in that. So we need to determine what's an acceptable tolerance for a device, as well as a target. We need to look at the lighting and how important lighting is in the influence of color. If there's anything you take away from this seminar, it is that lighting plays a huge, huge role on how you see color. We're never going to get away from some of that visual assessment, but if we can make that visual assessment as accurate as possible, then we're going to certainly help ourselves out significantly. And I'll give you a bit of a scenario. I was at a shop recently, we're doing G7, and one was a brand new press that had been in for about 8 months. And next to it was another press that had been there for many, many years. And I stood back and I looked down at the two press consoles and I looked at the light coming down. And the light on the left on the one press was yellow. It was like a basement from the 60s, you know what I mean? It had this yellow cast. And the one on the right was nice, neutral gray. And they both had the same background, but the background color you could see from a distance was different. And that was one of the first things I said. I said, when was the last time that those bulbs were changed? And they go, they don't know. You know what I mean? So a lot of people forget that the bulbs in your light boosts really only have a 6 to an 8 month lifespan until they start to deteriorate. So changing your bulbs with the correct bulbs, and we're going to talk about what those are, makes a huge, huge difference. And your ability to see color is hugely influenced by what you see through that lighting. So it's a big, big part.
Yeah.
If you're in the early stages of the design, then obviously your monitor plays a big part in how you can match that color. So we're going to talk about monitors a little bit. And in pre-press, we want to make sure that we have the right environment to be able to see lighting in there. And lastly, tracking colors. Tracking and trending and having that data becomes super, super important, right? And we're going to show you how tracking can sort of help you to see and pinpoint exactly where the problem is. Is it in the white point? Is it in the G7? Is it in the curves? It is in the, you know what I mean? Like there's so many variables that could play into it. When you start to track it, you start to be able to establish, oh, that is in the magenta unit on that press that we have an issue. So let's go back and take a look at it. So tracking and trending, it gives you so much information. So where are the causes for color deviations? One of the areas we see is incorrect RIP settings. So you could have one RIP with multiple different workflows, and in each workflow, you may have a different color target reference setting in there. You may have a different rendering intent. You could have a different spot color library. So the consistency in your RIP settings can play a big part in that. So obviously we want to make sure that we're looking through them all and we're using exactly the same settings for color management in each of those scenarios so that we're getting consistent conversions. The whiteness and the variations of raw materials is a big part. And I feel for you guys out there right now, because I know supply chain issues are really big and really challenging. And you're probably seeing more volatility in the media that you're receiving, and you know you're not having the opportunity. But if you can measure it, and I'm going to show you later in one of the trending graphs, you can identify that the issue is in the media weight point as opposed to in the curves or in the ink. So, you know, we can certainly eliminate having to worry about that by taking measurements of that. Printer maintenance is a big one. And I know it takes time to stop and do maintenance, but it's super, super important. And an analogy I give is, you know, a flatbed UV printer. Obviously, those UV lights are going to change their intensity over time. And they also usually have a glass below there. And sometimes ink comes up and sprays underneath and they get dirty. And that can be a cause of color shifting. So if you're not cleaning, you know, the shutters and the glass below the UV lights, you could start to see a degradation of color over time. Or another example is the light inks. Often they don't show the banding in the same way that a solid ink will, but they certainly will degrade the color. So if you've got, you know, nozzles that aren't firing, then of course you're going to see degradation in color. So that's a big one as well. Temperature and humidity. We have a tool that we can put into your environment, and it's a wireless device that basically will just take that humidity and temperature settings, and it'll go along. And all of a sudden, if you see a spike, you could get an alert on your phone that says, hey, you know, something happened in the shop right now and the humidity's gone through the roof. I mean, did somebody leave a shipping door open for 2 hours on a hot day? Is the air conditioning shut down? At least it gives you the ability to react and have that causality. So, you know, sometimes you don't have that invested into the system, but at least, you know, winter and summer, there can be certainly variations, and it may require different press curves for that time of year as well.
Yeah, I can add, Angus, as well, that regarding incorrect or RIP color settings, sometimes we don't have the time. So we create a manual curves. So it means that maybe the profile is, you know, it needs to be done, you know, another shot. So when you start to make manual curves, means that you should maybe look at the color, right? With where it was before, you know, a year before. Yeah, that's right.
Yeah, it's a good indication. Exactly.
Yeah.
So color references or targets, we said at the beginning, we need to have a target in it which we're trying to achieve. We need to make sure that we have the same one, but what is a good target? So in North America, we use GRACL. And if you guys are everyone's into acronyms, it's the general requirements for applications of commercial offset lithography. I knew most of you guys probably knew that, but that's what GRACL stands for. I don't know why they make the O small. I've never really understood why that. Maybe it's just aesthetics, but that's just the way it's written. So GRACL 2006, GRACL 2013, that is our North American target for sheet fed printing, right? That's our sort of the best of the best. And it's actually a very accurate standard that we can achieve, as opposed to previously, I think we had US sheet fed coded, which my understanding, it was taken from a proof, that it was just measured from a proof, and that became our reference. So the GRACL standard is built off of numerous press runs, and it has then been smoothed and optimized so that it's a great standard. So it's our target in North America. And Europe, they tend to favor more the FOGRA and the ISO, but they all point to the ISO 12647-2. So some people on the weekend might want to read a Robert Ludlum novel. I tend to read these things, and Patrice probably too. We tend to get ourselves into reading these. So this is worth the purchase. It's an ISO certification documentation that takes you through a lot of this stuff. And it's not terribly expensive, but it's certainly worthwhile if you're interested in learning more about the process control and targets and the whole thing. That it's a good one to go through. What we don't want to be loading is smaller gamut profiles for a gamut that we're trying to achieve, like GRACL. So, for example, Onyx by default will load the US web coded swap as the input profile, versus we're trying to achieve GRACL. So I always change it when I come across that, but that's where we come across those, what I call sort of incorrect RIP settings, and that may not be the most accurate. And the reason being is the gamut itself is smaller than what we're trying to achieve. So we have, the cluster in the middle there is that grouping that I said, which is the FOGRA and the ISO and the GRACL. The inside one that is green is the swap, which we don't want to reduce the gamut of our device if we have the ability to achieve GRACL. So we want to make sure that we're harmonizing those settings on all of the RIPs and achieving the best that we can. Some devices, we have new printing conditions now that can achieve more than GRACL. So if that's the end of the line for that device and it's going to be what's going to be presented to the customer, you might want to use something like a CRPC7, which is what we call extra large gamut. It's a larger gamut than is bigger than GRACL. So you give a little extra oomph and punch to that.
And it's still a CMYK color reference.
Yeah, exactly. That's a good point, because there is the ECG stuff that offers the orange and green. It's still a CMYK kind of enhancement of that.
Yep.
So printer versus reference. Printing system deviations often come across. So let's talk about that. So here we have GRACL as our target, right? But all of our devices in the shop, they're all as close as we can get them to the target, right? That's great. We want to try to get them as close as we can to that stick in the ground that we talked about, right? But the challenge comes in when we try to measure between devices. So a lot of times people will say, well, I'm matching to GRACL at 3 delta E and my other one is at 2.5 delta E. But when you add them up, you're past we add the two together, they may be not matching each other. So in this situation, the roll to roll and the wide format are an 8 delta E to each other, but they're still matching the target, right? So it's worth evaluating the match to printer as well as the printer to your target to make sure that we're still in the ballpark. And sometimes that can't be fixed. And at other times we can reprofile and look at ways in which we can make that get closer. It might be InQ that's different, or it just then we know, you can tell salespeople, we're not going to run side by side, campaigns on these two devices. It just can't be done. At least you understand that, but it's possible to get them closer. So we talked about what's an acceptable tolerance, and different devices have different tolerances. It's very hard in this visual example to know just how close these two are. I mean, the reds I can see are a little bit darker, the blues are a little bit darker, but it's hard to put a number on that. And that's why we say using a visual evaluation system is really difficult, because it's really hard to put a number on it. And it's obviously extremely hard to duplicate. But in our world of color, one of the terms that we use a lot is delta E. And delta E is a great mathematical formula for determining how close two colors are. So, you know, you have two greens, you measure one, you measure the other, and you get a delta E value. The delta between the two will tell you how close they match. It's a mathematical formula. There's a number of formulas. We use delta E 2000. That is the standard in our industry, because it translates the best to our visual system. But there are other systems out there. So we want to use delta E 2000 as the formula. And as a rule, 0 to 1 is really considered a perfect match, right? If you were to get a batch of 0.8, no customer on the planet would be able to complain about that, because it's extremely, extremely close. Like, some people can't even see the difference, versus getting up into the 2s and 3s. Now we can visually side by side see a difference. So most proofing systems, we're trying to get them within 2.5 or lower to grackle, right? Because we're not really, you know, that's the ultimate goal, is to try to get down as low as possible. So a proofing system, we're looking at 2.5, but a printing system like an offset press, it has modulations. It has a lot of different variabilities, and you'd be lucky to keep an offset press, you know, below a 3.5 or a 4, right? Especially if you've got multiple builds. If you've got a 3-color gray, you know, maintaining that through the press run, you're going to see modulation. If you have a single spot color in a unit, then you may be able to maintain that spot color, you know, maybe below a 2.5, but multiple builds on a presser are certainly going to be challenging. So in the next slide, this is an evaluation of 200 samples, and these samples are taken at intervals. So this is a long press run on an offset press. And what we're seeing is within sheet variability, as well as what we call the E factor. So the purple is the E factor. It's our expectation factor that we use as a way of, it's like delta E, if you will, to the target. So the green line is our target, and you can see that in a press, it changes over time. It comes in and comes out of its acceptability, and that's just the nature of the beast. I mean, some presses are going to be better than others, but it's the nature of that machine. It's just it's a metal machine that's printing color, right? And it's just not easy to maintain color over time. You know, comparatively, if we look at an Epson proofer, here is 800 samples. So we will take the samples from the SpectraProofer that gets uploaded to the cloud, and we can trend and track that device over time. And here our target is a 3, and this device averaged a 2.1. You can sort of see in the upper left-hand corner next to coded is our achievement, right, is what we're doing. So that's pretty good. This device is maintaining, you know, a pretty solid, you know, consistency over time. If it started to drift above that, consistently above the green line, then we know it's time to recalibrate that device to bring it back into an acceptable level, right? So that's the beauty of this, is, you know, we get the odd spike above, which is really could be, you know, a nozzle out or some issue.
Yeah,
Sorry,
regarding this slide, Angus, did you see the delta E, or the E factor, is 3, which is, as a rule of thumb, that's normal for a proofing system. So because this is our master file, master proof, so we will rely on this proof. So for the rest, you know, for the remains of the printing system.
Absolutely.
Yeah.
Absolutely. So that's an Epson proofer. The new age of printing now, we're looking at the inkjet presses. You know, the big manufacturers all have them. We're not here to do a sales job, but I'm just sort of showing you the stability of the new inkjet presses now is absolutely crazy. I mean, this is like down at a 1.1. I don't know why we had a pass of a 5, because we could probably put this down at a 2.5, but this one is trending at a 1.1. So we're moving in a new direction, and it's really interesting to watch some of these. I've been at an inkjet press where it looks like a Ryobi press. You send one sheet through and it comes out and it's perfect. It's sort of a bit of a brain thing, you know, and you're going to go, wait a minute, that press prints one sheet and it comes out perfect. Like, well, not perfect, but extremely accurate. So it's interesting where we're going with these new presses. So lighting influence, we talked about how important that is. So looking at the lighting within your organization, there's a number of factors that play into that. One is the age of the bulbs. were the bulbs, manufactured in the 2000s, but also there's other factors involved. It's the color rendering index. So this is something that manufacturers will put on the box in order to be able to give you a indication of the quality of the bulb. So CRI of 80 is very poor. A CRI, it goes to 100 is perfect. So a CRA of 97, 98 is very, very good. So we want to have a bulb with a high color rendering index. And we also want to make sure that we're replicating daylight. So Lord Kelvin, if we the Kelvin color scale, and we'd say it's 5,000 Kelvin. Lord Kelvin heated a rod and it went from orange to yellow to white and then blue. That white component, for some reason, is where we see light has the least amount of influence, color influence. It's daylight. So if you think about, if you can't get a color match under something, sometimes go to a window, where, you can get daylight coming in and evaluate it there, because daylight, 5,000 Kelvin is trying to replicate a cloudy day at noon. That's sort of the analogy, if you will. So, take it outside and look at it. I've been in shops where I don't trust the color and I go out the back door and I look at it, I go, okay, it's okay. You know what I mean? I can get a comparison to that. So daylight is our goal. We're trying to replicate that in a light booth. So let's look at an indication of what the bulbs would cost and really what you're going to get out of it. So ISO 3664 is a new certification, relatively new, that creates a stricter set of tolerances for our bulbs. So an ISO 3664 bulb is going to be more expensive than a generic bulb for sure, because it has to pass that certification. But you're going to know that it has a higher tolerance for color fidelity, right? Previously, we're using an ANSI tolerance. Now we're using the new ISO tolerance, which is tighter, but it's also taking into account the optical brighteners that we're finding in paper. So a lot more papers today are a blue-white paper. That's why Grackle 2013 was introduced, is to handle this flood of papers that are sort of a blue-white and sort of the fluorescence that they have to deal with. So the new bulbs tend to deal with that better. And this is really interesting. So a $5 bulb, what we did is we did looked at the wavelength and we took a snapshot of the color spectrum. So you can see the peaks and the valleys, right, of that bulb, of how it's going to render color. And the green line is our target on the bottom. If we look at a $40 bulb, again, it's not perfect, but it's substantially better. Now, if you look at the bottom where our color rendering index is where we want to be, we're much closer on a lot of those colors than we are on the bulb on the left. So I'll show you another slide which shows that. And this one shows it really well. Again, the bottom is 100 is the CRI is the top. So you can see the spikes up and down along the bottom graph. The ones that come near the top are going to be colors that are replicated accurately. The ones that are low, and some of them, you may not be able to see this, are down around 50 or 45%. So some of them are significantly being degraded due to the light. And this shows you what colors are not going to be reproduced accurately, right? Versus on a bulb that is, been ISO certified, is purchased from Just GTI or Just Normlich for the bulb. Yes, you're paying more for the bulb. You're not buying it at Home Depot. You're getting a bulb from the manufacturer, but the quality of that, the CRI, the color rendering index, is what we need to be able to evaluate color, right? It's super, super important. And this really shows the story, how the two bulbs really, how different they are and what happens. Can your monitor accurately represent what's happening on the print? In pre-press, I can respect that a lot of jobs this pass through, so we might not be doing so much, monitor evaluation. But if you do have the need to do that, then we're going to need to set up a monitor that has the capability of being calibrated. We'll explain that in a sec, as well as it's not in a bright room. So, you can purchase an LG or a BenQ or any of these kind of, not so much BenQ, but a lot of the lower end monitors from HP or ASO or Asus for around $250. And they look nice, but they have very poor color evenness, right? From side to side, you're going to see major differences and very minimal calibration capabilities versus a higher end monitor from ISO or the NEC SpectraView, and even the BenQ has a calibratable monitor. because it's hardware calibration, because you're able to calibrate the red, green, and blue guns individually, and the software takes control of the monitor to adjust those red, green, and blue guns to get the color temperature, as opposed to the software lookup table doing it on top, you're getting a much, much more accurate representation. And I recently came across a Dell monitor, and probably there are other ones, that right at the bottom had a little calibrator that popped up and right at the base, and it would calibrate the monitor at a specified interval in time and then go back down. So you could set it for 2 in the morning, every 30 days, it would wake up the monitor, it would warm it up for 30 minutes, it would take the measurements and do the calibration, and then the little piece would go down and hide again, and it would then be calibrated. So, it's pretty cool. Some of the self-calibrating monitors, I know that ISO also has one of those. So, but they're not cheap, but they're certainly worth it if you're doing, high-end color representation.
Yeah, just a small test you can do is just to put on Photoshop, for example, just to generate a very light gray. Just to fill all the screen, you'll see that the evenness of the color will shift from one corner to another. So without having a colorimeter or whatever to measure,
it's a good evaluation.
It speaks by itself.
Yeah. Cool. Good idea. So we also don't want to be in a really bright environment. We want to make sure that, we're in a dimly lit environment. I have this office in the back, and I tend to shut the shades and I close the door, and it's gray. And my wife comes in and is like, why are you working in the dark in the prison here? But it's the best way to be able to evaluate color on screen. I don't get reflections. I can see the color most accurately. It's ideal to be in a dimly lit room, of course, with just task lights. So tracking colors. If you want to implement color management, one of the most important things that we can do is to measure, right? Once we start collecting that data, then we start to be able to make really informed decisions and be able to see when and where and why. We get what I call causality, right? We get to be able to see what's happening and why. We talked about the white point, and we're going to show a little sample of that in a second. But if you can't measure it, you can't control it. That's really our motto on this type of stuff. When it comes to your tires and the PSI, obviously you get the warning indicator. You're not going to just do it by eye. You're not going to pump up your tires and think, well, that looks good. You're going to measure it. You need to have a measurement in order to have the conformance to the standard, right? And we all know that X PSI is going to be what the tire manufacturer recommends. So it's a simple analogy, but you get the idea. Here you can see this is the tracking and trending of a device. And what's really interesting is that the gray line is our color, the blue line is within sheet uniformity, and the gray line is the white point. So in this case, we had the wrong media used in this printer, and it was failing on the color, because now all of a sudden the fifth color, being white, is influencing what's happening to the color, and we're getting a fail. So after 10 or 15 measurements, they see this problem. They say, wait a minute, let's go back and check. We correct it, and now we're starting to trend downward. And after a couple of tests, we're starting to get this printer back into its normal conformance, right? So if we hadn't have done this, maybe we would have looked at it and thought, well, is this an issue with the curves, issue with the profile? We could have chased our tail for a long time. At the end of the day, it was really easy to see that the media was the issue. So that's why I say when tracking colors, you're able to very quickly, get an idea, what's happening, where the problem is, if you will.
Yeah, and sometimes maybe just a recalibration is just enough, to bring back where it was to the original state. Yeah,
exactly. So here's an example of a customer where we had 5 canvas printers. They print all day, every day. They've got an online, customers submit their images, and they were saying, we're starting to see volatility. At some point, we're getting, bad color, but we don't know when it happens, right? We're not sure at what point there's a problem. Customer calls us and says, it doesn't look right. My grandmother looks too red, or whatever you have, right? So they get rejects. So we went in and we implemented a daily procedure. So every morning they print this target out. It's in the RIP. So all they have to do is go print. They don't have to submit it. It's local at the RIP level. And they give it 10 minutes, and then they come over to the I10. They cut it on the line. You'll see here that it's a template that needs to be cut a certain way so that it fits on the I10 at a certain spot. Let me just start this for you. And he measures the barcode. Once he measures that barcode, that tells the software what Q, what resolution, what media, everything is embedded in that barcode. So the software knows what he's measuring. It doesn't matter what order he puts them down on the I1IO. He can go 175. It doesn't matter. As long as he scans the barcode, the system knows what he's doing. It also knows where on the table to measure, right? Because we set the XY positioning ahead of time, right? So that he scans it, and now the I1IO goes out and scans. This is part of their SOP. So in the morning they do this, right? And they go through and they do a scan for all the devices, all the presses. This takes him about 30 minutes in the morning. And this is part of his morning startup. And now we're back in the software, and you can see he's received a pass. That's all he cares about. If he gets a green checkbox, then he can continue his day. He continues on printing, and he doesn't care about anything else. This individual is not a color management expert. He doesn't need color management skill. He's a print operator, and not to diminish that, but I'm just saying he doesn't need to understand other than a green checkbox, right? As long as he gets a green check, then he can continue on and print for the day. If he gets a fail, the SOP says we need to go back, check the media is loaded properly, make sure that there's no nozzle issues or deflections in the nozzles, and run a nozzle print pattern and reprint it. If he gets a fail again, then that printer is decommissioned for that moment, and he calls management to come in. They then look at it and decide, do they have to do a new profile on that device, which is a 45-minute process through the RIP that they're running. It's pretty quick. You print it, you measure it, you reload it. It brings them back to the baseline. Just reprofiling will bring them back. So if that device deviates over time, we find out when it gets to the fail point, we stop, we recalibrate, and we bring it back to its baseline, right? So this is a really powerful tool for them. For now, they're not seeing the rejects, and they're just able to print with confidence, right? So they know ahead of time when there's an issue. No, that jumped ahead. Okay, so the next part of this is the equipment that you can use on site to be able to do this. So there's multiple levels and multiple press points that you can use, or price points that you can use to collect this data, right? We need to be able to collect data. We need to be able to, get this into the software somehow. So X-Rite is pretty much one of the, X-Rite and Teshcon are the two major players in the spectrophotometer field. The i1 Pro 3 is the latest and the greatest from them. It has a larger aperture, a new light source, warms up a little bit quicker, and it's considered to be a little bit more accurate than the original i1 Pro 2. If you have in your shop the i1 Pro 1, the difference you would notice, it's pretty much all silver. It doesn't have black on it anywhere the way this one does. The i1 Pro 2 and the i1 Pro 3 are both excellent devices. Both work really well, but I would not recommend, if you have an i1 Pro 1, to use that in production. You need to upgrade that one. So you could use the i1 Pro 3. It comes with a ruler, and you can scan by hand. It's a little slower, but it's okay to start that way. If you want to incrementally, start off versus adding the i1O table, which you saw on that last slide, offers the automation component, right? So I do like that in a busy production environment, like we showed you with the Canvas printer. The i1IO certainly automates that. It gives them the ability to kind of just quickly, boom, 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 move through them all. The Barbieri is the Mercedes of them all. It's an amazing device, comes with multiple apertures. You can change those apertures. What were they again, Patrice? I always forget. 2, 5, and 6?
2, 6, and 8.
2, 6, and 8. So you had 8-millimeter aperture for those devices that require, they're a little grainier, or a little bit, could be a fabric, could be, dye sublimation, all the way down to 2. Yeah.
Transmissive as well. Yeah.
And transmissive, exactly. So that's one of the big values of this, is that you can do backlit. It produces beautiful backlit profiles. So some of the best that I've ever seen. We used to have to use, it was like the DPT 20. We fed it through. That was back in the day. So anyways, it's one of the few transmissive devices that's out there that can do reflective and transmissive, and the color quality is great. Handheld equipment. Let's say you're a packaging, printer, and you print a lot of spot colors at press, and you're getting drawdowns at press, and you need to be able to match that and get a sense of how accurate you are on press to the drawdown. So ink supplier supplies you with your drawdown, you're right at press. You can use either of these devices to measure that sample. That becomes your target. And then as you're printing, you're able to measure the sample coming off the press and get a delta E. So if the customer is a picky customer, then you're going to want to make sure that that match is under a 2.5 delta E. You know, I've had customers who, you know, say 2 or less, and it's not impossible for a spot color to get that, but it's got to be ink formulation has to be very, very accurate on press for the hue. If, for example, this is another neat thing that it does, it'll tell you you're 4 delta E away, but in the best match window, which you can see on the right on the X-ray, it's going to tell you you need to go up or down in density. So it's a great tool because you're on press and you're not hitting it. It says, okay, you just have to go up on density. If you get to the point where you can't change the density and you can't match the color, now you have a hue issue. So at that point, it's saying you're a 4 delta E, but there's no move you can do in density because really it's light and darkness. You've got a hue issue. Now you've got to go back to the ink manufacturer or ink, whoever created that ink for you on the press and say, we need you to reformulate this ink because it's not the right color. We're never going to get there. So it's a really powerful tool for that. And I think having this at press is a really great tool. I think, you know, every press should have it out there. You can measure dot gain and you got the full Pantone library loaded at those. So you can do spot checks, you know, on digital jobs. It's a really, really cool tool. So we have software that we supply, and you know, this wouldn't be a seminar if there wasn't a little bit of a sales hook in here. So we're going to give you a little bit of the sales hook. So Chroma Checker is a cloud-based solution that Fuji sells exclusively in Canada. It is very cool because it doesn't really care what you're printing, what device you're using, right? You could be using, you know, you could have HP printers, you could have, you know, OSE printers, you can have Fuji printers, you can have whatever it is, it's agnostic. It doesn't care about the output device. And it also works with, it has, you know, an ability to capture from pretty much every device. So like I said, the SpectraProofer we can collect info from, a lot of the closed loop color scanning systems we can capture color for and upload that to the cloud. It can be the I1IO that I showed you, you know, that can be very easily implemented into their capture software, which I showed you that, you know, with a barcode, you can click and bring that in. At the beginning, I talked about data, and I talked about how important it is to start to pull data in so you can make informed decisions. This software allows you to sort of do that and get a sense of where you are in your organization, right? Are you printing sellable color? So once we establish tolerances for that device, we trend it and track it, and we want to make sure that it stays within that tolerance, right? Super, super important and a very, very cool tool. So this gives you a little thing as a color conformance platform, adapts to the needs of the shops and to monitor colors and printing. And it allows you to intervene when colors do deviate, you know, from their tolerance. What do you think, Patrice? Anything else add on the Chroma Checker side?
Well, again, this solution is, you know, remember at first we said that simplicity. So this thing is, it's in the cloud. So what Angus showed you regarding the scanning barcode, so everything is done. Once the measurements are done, they are up in the cloud, and you can have access to from the website. So this is either you're on the spot or you're at home, you can have access to all those metrics right away. Yeah.
Right. They even have an app, and an iPhone app, and all those types of things. And they've got some cool tools. I mean, it not just does that, but it helps with the G7 color calibration. You can implement all the G7 curves within that software. You can verify and validate your light boosts. You can verify and validate all of your measurement devices through this. So it comes with the target. So when I set up somebody with a new exact, we'll measure this target 3 times, and we'll set its baseline. And then every month, the software will remind you to check it and make sure that the device is still conforming to its original calibration. And if it deviates from there, then we know it's got to go back to X-Rite for recertification. But recertification with X-Rite is around $1,000 Canadian, and they recommend that you do it once a year. If your company demands that, then great, go ahead and do that. But if you can use this program to validate that the device hasn't drifted, you could go on for a long time without having to send it in until it does deviate, right? So
Yeah,
it could save you a little bit of money that way. It works
and based on the tolerance set, you said, is it sellable or not sellable? So it's just a green light or a red light. So this is depending on, the tolerance sets you applied for print device. It must be higher for a digital printing device, or maybe a tighter for, of course, a proofing system, or a more an offset press. But again, green light or red light. That's simple.
Data driven. So we were talking about capturing measurements, getting more measurements in. The more information you can gather from there, again, you're hopefully going to try to move that from being a visual base to a database and more of a metrics of collecting data, right? So that's pretty much the end of our chat. I just want to say that at any time, if you guys have questions about color management, both Patrice and I are 100% open to just, send us an email. If you got a problem, you've got anything that you're coming across, we actually enjoy color management conversations. You know what I mean? It's sort of what we do, and we thrive on those challenges. So if you guys have a challenge in-house, we're going to get you our contact information by the end of this. You don't have to be a Fuji customer. Fire us an email and chat with us, and maybe we can help you out along the way. So that sort of concludes things, and we'll pass it back to see if there's any questions that came through there.
There we go.
Thanks so much for that, Angus and Patrice. I do have a number of questions here. First one says, hi Angus, is there any other way besides using the I1 profiler to read charts within I1 ISIS?
Is there any way to
very particular and a little bit flaky?
Yeah. I mean, there used to be a program called Colorport. I don't know if it's still around anymore. I mean, I1 is you don't have to purchase the full building the profile. You can download the software for free, I1 Profiler, and you can measure charts with that. And then you can export that as a CGATS file and bring that into other software. So I1 Profiler is really I don't know, Patrice, can you think of anything? I mean, Barbieri has their own tool.
Yeah, well, I'll think about maybe, Color Ant from Color Logic. Color Ant may be a software they can,
that's a good idea.
ISIS can work with that software from Color Logic.
Color Ant's a very powerful tool for color analysis called Color Ant from Color Logic. So we use that for smoothing, averaging, and analysis of color. So that might be another option.
Yeah.
This person followed up and said that they did like Colorport, but that they find it doesn't seem to work with the new device.
It's old.
Yeah,
no,
it's pretty old. It's too old.
Yeah,
that's the thing. Yeah, we used to work with this a long time ago.
Yeah. But no, I would say, I mean, I don't know. I'd like to understand why you can't use I1 Profiler. Again, you can download it for free and you can measure in it for free and export those measurements. The only reason I see is if you're running Caldera, then the two of them tend to run, they seem to butt heads on some components, but okay.
Yeah. Okay. Would one of you like to expand on what you meant by when you spoke about the light standard ISO? This one's the 3664 by 2009.
Sure. So that one of it is there's a number of components to that certification, and one of it is the evenness of lighting in the light booth. So that's the manufacturing. They have to have a much higher tolerance in how the light is projected into the light booth, but it also relates a lot to the UV energy that presents at D50. So we see that due to the optical brighteners that are in the papers today, that they had to change the UV energy content in the bulbs, mainly because the papers with the optical brighteners tend to fluorescent within there. And it helps to create a closer match with those that do have the optical brighteners. The downside is if your media paper doesn't have that, you may get into a situation where there's even a bigger mismatch. So if in implementing an ISO 3664 bulbs and you see your press sheet and the proof is going very yellow, then you may need to block that UV with a filter, and that is possible from the light booth guys. They can put a filter in there to block that out if your proofing paper doesn't contain that. But for the most part, it's dealing with the optical brighteners that are in the papers today and trying to bring a closer match to that.
Yeah, one thing, Angus, well, people that, sometimes a lot of time we are going to a plan to say, oh, by the way, we changed all the light on the ceiling. It's
Yeah.
now 500,000 K. So
Yeah.
yeah, it's just a color temperature. We don't know the CRI is whether it's good or not. So you
Yep.
might, be close to 5,000.
Sure.
But the thing is, the CRI may be pretty low. So you remember the graph that you saw earlier? That's
Yep.
a good example that some color may be okay, but some maybe out of range, I would say, to evaluate.
Exactly.
So
And
good to
in a
know.
lot of the Pantone books I'm seeing now, on the last couple of pages, they have a light indicator that'll show you, if the sort of orangey brown blocks match up, then your light is D50 and in a good state. It's not giving you, a detail like we showed you before, and then there's also the REM indicator stickers from GATF that allow you to see the stripes. And, I use those all the time, and I show people, I mean, this lighting is absolutely not okay. And just from the sticker standpoint, right? So look at the back of the Pantone Pantone books, and there may be a light indicator sticker there on the newer ones that you can look in your light booth. And if those two blocks are the same, then it is more true D50, but a lot of times that's a quick way to check things.
Thank you. So you didn't mention G7. Is this still recommended?
Absolutely. I mean, G7 is a great tool to create what we call sort of shared visual color appearance between multiple different devices. It took off. I think it was very popular when it first came out, and people felt that they needed to be G7 certified in order to, retain that kind of level. Today, I see probably a little bit less because maybe print buyers aren't demanding it, but it's still a very, very good tool for press calibration. I mean, when we go in, both Patrice and I do a press fingerprint and press calibration, we're using the G7 methodology every single time because it is the best way in which to fingerprint and calibrate a press to match a proof, hands down. You know what I mean? I wouldn't use anything else. Whether the customer decides to go the extra step to become a G7 certified master facility, that's up to them. I mean, there is some extra value to that when it comes to that, because I'll be on the ID Alliance website. You have a plaque, you have, things you can send out to your customers to say, we've achieved this level of conformance that's sort of maybe above and beyond, the everyday printer. Our proof has passed the color space and our press is passing targeted. And it means that we should have a pretty good match. So there's still a lot of value in it. When we were talking about today was really, ways in which you can sort of quickly maybe assess color, but it is a part of that. I mean, the calibration of the press, absolutely.
Yeah, and I would add on the digital side. I mean, with a digital printer, when you create a profile, there's two main things that the profile will look at. First, the color space itself, to get all the boundaries of the colors, and neutralize the gray. That's the two main functions for an ICC profile. Then, so if you have a good profile, chances are good that you're right from the start, your gray balance will be pretty neutral. If not, something went wrong. So you need to check that side. Yeah.
That's a great, and all of our test images, 3 and 4 color grays are one of the most predominant ways in which we evaluate color, because if you draw a linear grayscale with 4 color grays, right, your black's going to start at 30, you got CMY in there. If you have a nice neutral gray from start to finish, nice, even, smooth gradations, I'm going to say 99% of your profile is done. Right. I mean, the gamut and then some of those other things are part of it. But that in itself is one of the best indicators of good color profiling is neutral gray, right? And you want to view that in, obviously, good lighting so that you're not seeing any bias of the lights. But for me, when I'm evaluating what we've done on press, I first go to my gray balance charts and I look at those and I see, okay, I've got a nice, smooth, even gradation. There's no bumps in there. And it's neutral gray going right through. Because, back in the days of photography, we used neutral gray as the baseline with which we were able to calibrate or, set our press pictures up, right? Same with scanning, the scanner operators, which I was for a while, we would use neutral gray as our baseline to correct images. So, it's still a very important metric. Yeah.
So you mentioned early in the presentation to do a color comparison between your shop printers to determine the true delta E difference between them. What's the easiest way to do that?
What's the easiest way to do a comparison, a delta between in your shop printers? Is that the question?
Yep.
Okay. Well, you need to measure that. You need a tool like a Teshcon or an X-Rite. You need to be able to measure the two side by side. One becomes your standard, one becomes your comparison sample, and you get a delta E value for that. Do I have my I1 here? I won't get into it now, but it's a pretty simple process. You take a sample and you do a comparison, and it'll tell you, the delta E value between the two. That's where the Exact and the Teshcon and SpectroScan are invaluable tools to be able to do those spot measurements, at any time. It is possible, I think, with the I1, but you're tethered to a computer, and it's a more cumbersome. You need software to interpret that information, and then maybe you take the LAB and you put them in, Bloomberg's website, to get an a delta E value. But it can be done other ways.
Excellent.
Yeah.
What is the recommendation for monitor calibration?
Well, there are defaults within the software. And one thing is to note, X-Rite sold their monitor calibration division to Calibrate. So the I1 display and the passport and all of those sort of what I call pro-consumer tools, X-Rite no longer sells. They've been passed on to a company called Calibrite, C-A-L-I, Brite, B-R-I-T-E. They're now the distributor of that product. So they put their name on their product and they take it over. Within that software, you're going to have options for presets, if you will, for calibration. So you could have, photography, you could have printing and press, and all of those. So within each of those, you're going to have gamma, you're going to have white point, and you're going to have luminance. The luminance is one of the most important ones. Yeah. And today's monitors are out of the box, probably 200 plus lux, right? They're super, super bright. Unfortunately, there's no paper on the planet that can print that brightly. So we have to dumb down the luminance, usually to 160. Some people might go as low as 140. So we set our luminance to a value. We adjust our red, green, and blue guns. This is done through the software to a color temperature. I tend to pick 6,000 Kelvin. That's been my go-to for monitor calibration, because unless it's a super high-end monitor, I find personally 5,000 Kelvin on the monitor visually looks too yellow to me. Even though we're trying to target 5,000, I find a disconnect. You can experiment with it. You can do a 5,000 Kelvin calibration and look at a piece of paper that is your press sheet, just a white sheet, and do an evaluation that way and see if the white point on the two match up. But my experience has been that 6,000 is a pretty good color temperature.
Yeah, 5,000 is more on the peaky side compared to a piece of paper. So 5,500 to 6,000 is good. And close. And let's say for an ambient light environment, let's say 160 candela per square meters, not more than that. Otherwise, you're gonna, it gets your eyes, you're really, really, weak after.
But a lot of these softwares will have presets that I would start with and use that preset, and then they'll have an advanced option to be able to go in and do a little bit more. And, do you go in and go into the menu of the on-screen display and make changes to the red, green, and blue guns manually, or does the software allow you to make those changes automatically? It's great when it's kind of a bundled solution like the NEC SpectraView. BenQ has their software, which takes control of the monitor. NEC and some of these other ones are, and ISO, of course, as well, will control the full calibration process. So all you need to do is just hang the puck and push the button and come back 20 minutes later.
Yep.
Excellent. Well, we do have just a few minutes left of our presentation today. So I was wondering if, Angus, you would like to leave our audience today with any single pieces of advice or the biggest takeaway that you would like them to have from your presentation today.
Sure. So, having a measurement device on site to be able to equate color differences, to take the subjectivity away from the process. We've had some, large, wide format, grand format printers, for example, who have been using subjective analysis, and they'd run out a spot color chart, and then everyone would come around and try and say which one is closer. And then I would go, okay, let me take my Exact out and do a comparison. And I go, click, 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 click. That is the closest one. that is definitively the closest one to the Pantone. And we've got 40 samples. That took me all of 45 seconds. Being able to measure and get a definitive value for color matching is super helpful, because in this situation, we had the salesman there and he had his input. We had the press operator, he had his input, and we spent 20 minutes, everybody going back and forth doing stuff. When I did that, I said, it's a no-brainer. That is the closest one. Everyone stopped. Okay, on to the next. You know what I mean? Like, measurement-based information is super powerful and takes the subjectivity out of it. And a handheld device, again, I talked about 30 minutes and what does that time cost you? They spent 30 minutes just sitting around trying to decide on that. And this is a shop that does, you know, $4 to $5 million a year. So what is that 30 minutes costing them? That's a lot of money. So they pay for that device in 6 months through, you know, just saving that time. So get measuring, think about what is a device that you can use. You know, there's lots of online tutorials on how to use those devices. If not, you know, I've got videos that I can share with you, and we're happy to help you any way we can.
Well, yeah. So we were at the graphic arts, and now we're go towards print manufacturing. That's the goal. Yeah.
That's the goal. Exactly.
Yeah.
And look at us, 3 o'clock. We did good.
Perfect timing. So it does look like we have reached the end of our session today. I want to say thank you to all those who took time out of their busy schedules to join us this afternoon for our webinar. I want to thank, of course, Angus and Patrice for their excellent and informative discussion. And thank you to Fujifilm, without whom today's webinar would not have been possible. If you did tune in late this afternoon, it has been recorded, and a link to the recording will be sent to you along with some contact information for Patrice and Angus should you wish to reach out in 24 hours. I hope you all took some great information from today's webinar. Once again, I'm your host, Chehalis Newbound, and I wish you a safe and productive rest of your day.